Hey, Shua.
Hey Brittany, how's it going?
Good, good. I just got back from the field. I collected some awesome data with the RS5. I'd love it if you could take a look.
Great, I'm looking forward to checking it out.
All right, see you later.
Bye. Today we're going to be covering the basics of the RSQ software, which goes along with the RS5 system, but also opens M9 and S5 data files. So I'll go over some of the basics, how to open the measurement, how to review it, some of the best ways that I like to use to make sure that the data are complete and are good. And then we'll go over some other post-processing tools, how to wrap up the data file, discharge summaries, all of that sort of thing. So let's just jump right into it. So I've got RSQ open here in front of me, and I'm going to open Brittany's data file. To do that, I just go up here to the upper left, open file, click on it, and I should see data files pop up. Now, I'm opening an RS5 data file, but you can also open M9 and S5 data files as well, simply by clicking Shift and then the Open File button. So again, let me open Brittany's RS5 data file, and here we go. What you see is the general sort of landing page when you open a data file. This is pretty much identical to what you'll see in the field during a data collection session. So let me just point out again what the various windows and screens represent. So on the top left here, you've got various icons to tell you the status of certain data streams coming into your system. And then a tabular here where you can add or remove any sort of parameters that you want to see in the field or in post-processing. Along the top here, you see a whole bunch of tabs. These are all the transects that Brittany and Isaac had collected in the field. You'll also see that there is a loop measurement and an SMBA. Those are the moving bed measurements that they also collected in the field. So everything is brought together in one place under one data file name. So this just makes the whole process a little more streamlined compared to separate data files. So in the central window, you'll see three plots. The top plot is a plot of various parameters that you might want to see during the measurement or in post-processing. So what I like to see in this first window in post-processing is to plot the vertical beam and bottom track beam depth. That's represented in these rainbow colored lines here. And what I'm looking for is a similarity among all of the lines. So I don't want to see any big outliers or anything like that. So right now, these look pretty good. They're on top of each other. You'll notice that sometimes one color will have a gap, like right here. This means that, for example, here this black line, which represents the vertical beam depth, for whatever reason didn't get a proper return at that location. So what happens automatically with the RS5 and with the M9 and S5 is that if you're missing a vertical beam depth, the bottom track depth, which is the average of those four skew beams, that will fill in for you, so you don't really have to worry about missing data. I also like to plot other parameters on this right axis. Currently, I have magnetic error. I have this because generally we like to use GPS as a backup track reference. And so with GPS, you want to be concerned about the magnetic error. So in this case, we have magnetic error that's hovering about 0.2% on average, and that's fairly low and nothing to worry about, so that's great. So in this central window, we have the ship track plots. You'll see various colors representing different ship tracks, blue being the bottom track, and GGA and VTG being the purple and the yellow tracks. Those are your GPS ship tracks. In this case, they were able to use GPS during their measurement, and so you're able to plot all three tracks. We can, in post-processing, decide which track is best to use based on the data quality and certain other parameters. So in terms of data quality, I like to use this window to determine if I have any errors in our ship track based on bottom track or on GPS. And what I'm really looking for is that all the tracks kind of are similar to each other, and we really want to see tracks that lie on top of each other. On the bottom window, we have the color contour plot. Now again, you have the choice of plotting various parameters. You can right-click on this and choose the parameter of choice. What I like to do is to choose water track and the speed. This gives me an idea of the speed of the water, and I can tell very well where the highest speeds in the channel occur and where the lowest speeds occur, and make sure that that makes sense for your measurement. So in this case, as I flip through these transects, these are separate transects going left to right and then right to left and left to right again, you can see the similarities in the colors of the contours, and that's kind of what I look for. I don't want anything to stand out that's abnormal, and I want to know that, you know, these transects are all well done and they make sense. You can see some reddish colors here, and let's see, wow, almost 4 meters a second. So it was really flowing at the site that they were measuring at. So let's go back to this left side here. The middle window here is the QC warnings window. You'll notice the yellow warnings pop up here in this data set. The yellow warnings represent warnings that users should at least know about in the field, and they're not necessarily warnings that you should address if you understand that they're pretty reasonable and correct. And then you'll see these red warnings where these are really the warnings that you should take notice of and try to correct in the field before proceeding on. So let's go back to the yellow warnings. We see that this data set has warnings for beam separation and bottom track that's used as a depth reference. So what this means is that the vertical beam, which was chosen as a primary depth reference, had some spaces or gaps in the data, and the bottom track depth was substituted in for those points. So this just tells you that you might have some gaps in your vertical beam, but don't worry because your bottom track depth is filling in for it. Secondly, the beam separation. Let's address those warnings. So when you click on any of these line items, you'll get sent right to where that sample is. So I've clicked this sample 373, and I see this line pop up. So this brings us to the bottom left box. This is the profile box. And right now I have plotted the SNR. And again, if you right click, you can pick different parameters to plot. But what's handy here for me is to plot the SNR so that I can see what the SNR looks like all the way down to the bed. So the 4 colors represent the 4 skew beams on the RS5. And you do notice that one beam is very different from the others. So what I really want to see is all 4 colors kind of collapse onto each other. And when we have a beam separation that's larger than about 10 dB, you're going to start seeing these beam separation warnings. This is actually beam 2 that's separated. That's one of the beams that, for them, they were pointing towards the banks. So I'm going to guess that because of the fast flow, the surface could have been slightly turbulent, and the boat could have been bouncing up and down in the water, and for whatever reason there could have been a little air entrainment or something else with the beam that caused it to have the separation. So for this data set in particular, I'm not too concerned about the separation, just because the separation isn't huge, even though you did get a warning. If you look at the very bottom SNR before the signal hits the bed, you'll see that it's still around 30 dB, which is still really reasonable for a good signal. If you see this creeping down to maybe a couple dB, like 3 or 5, values under 10, that's when you should start being concerned about the quality of your data. But this, to me, is still okay for now. If you look at the errors populated among the samples in your entire transect, you'll notice that, well, they're kind of spaced out and they're not too frequent. So in general, you probably have a perfectly good measurement with just some warnings that you may want to just, take a more in-depth look at. So with that being said, again, the transects are up here, and let's take a look at these loop and SMBA moving bed measurements. Brittany and Isaac were able to perform both a loop and an SMBA moving bed test in the field before taking their measurement. So let me show you how to access those measurements and then apply a moving bed correction to your full measurement. So the way to do that is to go to Discharge Settings, and you will go to Moving Bed Correction and choose either Loop or SMBA. So let's just choose Loop, and this will automatically open whatever loop file is associated with the data file. If you have multiple loop files in this data file, then you'll have a drop-down menu that has all of them populated, so you can select which one to use. So you'll see various parameters. You'll see the moving bed velocity as well as the flow velocity. The criteria for the moving bed, those numbers are crunched down here. And normally we use a moving bed percent of 1 to determine whether it's a moving bed or not. So in this case, the software basically determined that there was no correction recommended because the moving bed velocity was less than 1% of the flow velocity. So here I'm going to click close because I don't need to make any sort of moving bed correction. But if I were to make a moving bed correction, this is where I would choose to apply to a single transect or all of the transects in the measurement, which is usually the best practice. So let me click closed here. I want to show you a shortcut to access the discharge summary. That's where you will get all the information and the summary information for all of your transects. So I'm going to click Control S here. I'm showing this table because you'll notice this column that says total Q corrected. This is a very important column to highlight when you do apply a moving bed correction. Those values in the total Q, those will be corrected and put into this column. If you don't show this column, then you won't have your corrected Q values after applying a moving bed test. So in order to access this or any of the other parameters down here, you can simply right-click and toggle on or off any of those parameters. So total Q corrected here is the third from the bottom, and all you have to do is either toggle that on or off to get that or any of the other columns in your discharge summary. Now I did show you a shortcut, Control S for discharge summary. That's often very handy in the field. You can also access these windows using this window button on the top right. So let me click on that and I will toggle on or off this show summary panel, which toggles on or off the discharge summary. You can also show or hide that QC window on the left there, or show and hide a toolbox. Now the toolbox is going to be your tool to use for post-processing. So let me just show that toolbox to you right now. I have various categories here, and these categories actually match. If I click on the Smart Page, you'll see that they actually match the Smart Page information as I go down. So that's another alternative. If you want to edit your information from the Smart Page, you can, or you can have these quick links to the toolbox up here, or even use these Control-1, Control-2, Control-3 shortcuts in the field in order to access your various sections of your configuration. So as mentioned before, you can set up all these parameters in the field. It's best practice just to set them up properly whenever you start taking a measurement so that you do have an accurate Q and your velocities are accurate when you're out in the field. But for any reason, if you want to do any sort of changes after the fact, if you decide to change a track reference or a depth reference, this is how you do it after the fact. So let's look at the Smart Page and go through some of the parameters that were set. So you'll notice that most of the words here are in black, but some of them are highlighted in this turquoise color. That means that Brittany or Isaac had modified these values before this data set got to me. So it looks like they modified this edge configuration here, this edge method, they modified to slope. Brittany mentioned that before she had actually set this as a vertical bank. There is a slight difference in the calculation, vertical bank versus slope. Probably not a huge deal at this site, just knowing how fast the flow is here. But to be the most accurate, she changed it back to slope when she thought it was vertical bank at the beginning. In this next section, you do see these coefficients highlighted in turquoise. And this signifies to me that they likely used Extrap to recalculate the extrapolations. Now, just a reminder, the default extrapolations in RSQ are power. In order to change the coefficients, you can either change them manually by simply clicking this change button, and here you'll be able to update your coefficients, or you can use this Extrap tool, which was developed by the USGS. Now this tool is directly embedded into the RSQ software, so you can access it by clicking Discharge Settings, Extrap Method, and you'll see the Extrap dialog pop up. For those QRev users, this screen will look very familiar to you. It's the same code as what's used in QRev. And so here we run Extrap on our full data set, and this chooses the best coefficient that we use for this measurement. So once they ran this in the field, they applied this Extrap change to the entire data set, or you can apply it to a single transect if you want. But most commonly, you'd probably want to apply to all of the transects in your measurement. Once you've done that, click close, and those values should be updated for you. And again, all of these numbers you see on the bottom and all the numbers that you see in the actual software will be updated automatically, no matter what changes you make in the Smart Page. All right. Now let me go over some of the other parameters that I see commonly modified in the field, and those are contained in the System Configuration tab. So in order to modify these parameters, I can either click Change here, or what I like to do is to simply click Control-2 using these smart shortcuts. So Control-2 brings me directly to the System Configuration dialog. So they entered a transducer depth of 0.075 meters. This is usually the deepest that the RS5 can go in the hydroboard micro, and so I'm assuming that they did this because of the turbulent water and fast flow. Usually you want to lower the RS5 as low as possible into the board in order to minimize bubbles, entrainment, and even the system just coming in and out of the water. So I'm assuming that that's what they did here. You'll see that the magnetic declination is entered. If you do forget to enter that, you can enter it after the fact. Usually if you don't enter the magnetic declination, it'll be 0, and what you'll see is a split between your bottom track ship track and your GPS ship track, so they'll be at an angle with respect to each other. So just make sure you enter that in correctly if you do use GPS as your ship track reference. And then there's a screening distance here. It's 0 for the RS5. Now if you're following USGS protocols and you're using an M9, this value might be populated, and that's the default value that would be used for an M9. If you're measuring in salty conditions, estuarine conditions, or coastal conditions, you need to input a salinity, and this automatically will correct your sound speed for you and give you a proper depth and proper velocity readings. All right, so aside from these commonly adjusted parameters, down here, this is where you adjust some very important parameters for your measurement. What we have here is a coordinate system. So when I toggle this list down, you'll see many choices. Most people will use E and U. I've seen some people use XYZ when there's magnetic interference with the compass. That's also a choice available. You wouldn't want to choose this if you're using a GPS because you do need your magnetic compass. So if you're using your standard GPS setup, even as a backup ship track, you can choose E and U as your coordinate system. Now your depth reference. I was mentioning earlier that the vertical beam, because it had a couple gaps, the bottom track depth was able to fill in for that. Here, if you're noticing that your vertical beam has a lot of gaps, you can actually choose your bottom track as your depth reference. So there's just the choice here for you. Most of the time I've seen people use vertical beam for their depth reference, although some sites you might consider using your bottom track as your depth reference, but this is the way to modify that. And then finally, your track reference. This is a very important parameter, especially if you notice any sort of data quality concerns with your bottom track or your GPS ship tracks. Now, again, you want to compare all the different ship tracks and make sure that they're similar. If you notice that one is very different from another, you generally want to understand the reason why and then determine whether you should actually move to a different ship track to get your best measurement. Now, it looks like they actually chose GGA as their track reference. Generally, and most commonly, I see bottom track being used as the track reference the most. And there's nothing wrong with using GGA or VTG when you have good GPS quality data. I just see bottom track as the most common type of track reference. So in this case, when GGA was chosen, there must have been a reason for that. So let's go into that a little bit more. If we look at the total Q column in this discharge summary. Let's look at the bottom here. The COV value represents the variability among all of the transects. And generally speaking, you want to keep this at under 5%. Sometimes, at some more difficult sites, whether it's turbulent or maybe more fluctuating sites, you understand that you might have a higher COV, even 10% might be acceptable. But in this case, we see that the COV using that GGA ship track is 1.9%. So that is a very tight COV and a very good measurement. Let's see what happens when we switch back to bottom track. I'm going to click Apply to All and click OK. And again, those values are automatically changed to reflect that change. And you'll notice immediately that there are two red lines that pop up. So this red color represents a transect that is 5% or more different from the average of all of these transects combined. So we already see that there are some standouts here. So these two transects are very different from the other transects. The COV value here isn't too bad. It's at 3.5%, but it is higher than what we saw with GGA. So I'm going to infer that Brittany and Isaac in the field decided to use GGA to have just a tighter Q among all of their transects to get that COV value lower. So that's a totally fine thing to do, and it gives you a higher quality measurement at the end of the day. So again, just looking through your transects, looking at your total Qs, you also want to pay attention to, for example, your widths. Here, if you look at the widths of the channel, you can see some variability, especially using bottom track here. We go from 22.4 all the way to 23.4. That's a meter difference using the bottom track. If I switch back to GGA here and apply all, you'll see that that difference is quite a bit more minimized using the GGA as a track reference. You want to make sure that that makes sense. So in the real world, when you did actually take this measurement, was I really about 23 meters across that cross section? And then you want to look at things like the maximum depth. Let's see, among the transects, they're usually around 1.2, 1.3 meters deep. And make sure that that was also reasonable for your cross section. We don't want to see any numbers here that aren't real and reflect the real conditions. Left edge distances, right edge distances, make sure that they're consistent. I've seen lots of data files where someone just simply forgets to input a left or a right edge distance, and those appear as 0. If that happens and that's not the real case, then make sure to go back to your smart page and change those edge distances here accordingly. So once you've looked through all of your data and you're happy with the data quality, you've looked at your Q values and they look reasonable to you, the COV values are less than 5% or maybe less than 10% if you're at a very variable site, you're ready to close out this measurement. Some things that you can do are, first of all, to click the export button. If you wanted to plot the ship tracks on top of an actual map, we do have a feature called the KML export. Let me demonstrate that to you really quickly. So I'm going to click selected here, which is going to plot only this transect, but you can also plot all of the transects together on top of one another. Now, make sure that you actually have a GPS ship track reference when you use this feature, because if you use bottom track only, the RS5 or the M9 won't have any idea where you are in the world. So just make sure that you actually do have GPS when you select this feature. So let me just show you very quickly how to do that. Test, and Google Earth will open automatically for me, and I'll be able to see where Brittany just took her measurement. All right, there we go. So there's our measurement in Colorado. You can see definitely some turbulence on the surface, which goes hand in hand with my assumption that the beam separation, those warnings that we saw, were likely from some turbulence at the surface, bouncing the board up and down and possibly causing some of that beam separation. All right, another feature that I wanted to point out is if you go to export, This summary report is something that's very commonly used for reporting purposes and how many people close out their measurement. When I click the summary report, you will basically get a summary of the entire data set. You'll have a choice here whether to include charts or not. This choice can be accessed in Tools, Settings. So in this case, right now, I've chosen to include all of the contours and the plots, so you can have all of this information available to you in your report. You can have a summary of all of the measurements, and this is a reflection of basically the discharge summary on the bottom, slightly modified. So at this point, you can either choose to print or save this document to PDF and close out your records. Another feature that I wanted to point out is locking the measurement, which is important to many people because other people can inadvertently open a measurement and maybe modify some of the parameters and unknowingly change your measurement. So what you would do here to lock a measurement is to click this measurement session button on the top left and go all the way to the right here, Properties. You'll see that this measurement that Brittany gave me is actually locked. So I have to go through these extra steps in order to modify it. So I have to click unlock and save here. If the measurement is unlocked already, then there would be a lock button here that you would just simply push, and this will lock the measurement for you so that you can't actually make any more modifications. And then finally, for those QRev users, there's an easy way for you to import the data files into QRev directly from RSQ. What you would do is to click Export and Matlab Export. Now again, you'll have a choice of exporting the selected transect or all the transects. And all the transects, this option is much more common for QRev users. So I can either click this, which will begin the export process. All right, and this tells me the path where those files have been exported. Or I can access Tools, Settings, and if I go to Moving Boat, you'll see this choice here, Automatic Matlab Export. This is a toggle which will automatically, if toggled on, automatically export all of these to Matlab for you, so you don't have to go through all the steps of doing it manually. So this is kind of a handy feature for you if you do export to QRev often. So once these files are exported, let me open QRev here. I've got it pinned down in my taskbar. I can simply open those Matlab files that have been exported, basically highlight and open all of them. And there we go. So now I'm ready to do all of my post-processing in QRev if that is a normal step in your organizational process. All right, so I've gone through the basics of the layout of the RSQ software. Again, it's used for RS5 measurements, post-processing and viewing, but you can also open M9 or S5 measurements, again, by using that Shift and then Open File button. I've gone through some basic steps on how I like to look at data files and what different tools that you can use in post-processing, and some features of the RSQ software that you can use in your own post-processing. If you have any further questions, feel free to contact us at any time, inquiry@sontek.com. That's INQUIRY@sontek.com. And we look forward to hearing from you soon. All right, take care. Bye-bye.